All right, let's find the relative extrema for this one right here. Again, we want to find any points where we have a relative min or max. Excuse me, so now we can do that by again finding the derivative. Unfortunately, this derivative will involve the quotient rule. However, the good news is that this will simplify in a really good way, which I'll show you in a second. So to do the quotient rule, remember that it's low d high minus high d low over low squared. So that means on the bottom I have x squared plus 1 quantity squared. And on the top I have the low times the derivative of 8x, which is 8, minus the high times the derivative of the bottom. The derivative of x squared plus 1 is just 2x. So that's what I have right there. Now, what we need to do is set this equal to 0 to find any critical values. And what's nice is, because this is equal to 0, what we can do is just cancel the entire denominator. We can multiply the denominator over, and because we equal 0 right here, that means that the denominator just goes away. So now we're just solving the equation 0 equals x squared plus 1 times 8 minus 8x times 2x, which is 16x squared, just like that. So let's keep solving. 0 equals 8x squared plus 8 minus 16x squared. Keep solving. We get 0 equals negative 8x squared plus 8. Keep solving. We subtract the 8 over. We get negative 8 is equal to, because I subtracted it over, negative 8 is equal to negative 8x squared. Divide by negative 8, divide by negative 8. And we get x squared equals 1. Okay, take the square root of that, and we get x is equal to positive or negative 1. So that's it. That ended up not being that difficult to solve, luckily. Now we do the same game that we did earlier. We're going to check 1. And to check 1, let's check the points 0 and 2. And we'll check negative 1. And to check negative 1, we'll check the points, how about negative 2 and 0. Now remember, when you're checking these ones to see if they're a relative max or min, we need to plug those back into this derivative right here. So start by plugging in 0. I'm going to do a bunch of this in my head, but you could write out the steps if you need to. Plug in 0 right here. Well, first off, on this bottom, we plug in 0 here. The bottom's going to be positive. In fact, notice that the bottom is always going to be positive, because we have x squared plus 1 squared. So no matter what I put into this, it's going to be positive. So since I only care if we're positive or negative, we can ignore the denominator in this one. So plug in 0, I get 8 minus 0. So that means 0, we're increasing. The function is increasing at 0 because the derivative is positive when we plug in a 0 for x. Again, I plugged in a 0 here, so I had 8 minus 0 times 0, so just 8, which is positive. If I plug in a 2, I'm going to get 2 squared, which is 4, plus 1 is 5, times 8 is 40, minus 16 times 4, which is 64. 40 minus 64 is going to be negative. And so that tells us that we have a relative maximum at 1. And if you plug 1 into the original function, you'll find out that the y value is 4, so we have a relative max at the point 1, 4. Let's do the same thing for negative 2. Let's plug in that check. So negative 2 here will be negative 2 times negative 2 is 4, plus 1 is 5, times 8 is 40. Again, plug in negative 2 here. I get negative 2 times negative 8, which is 16, times negative 4, which is negative 64. And that's decreasing. It's negative, so that means the function is decreasing right there. So that means this negative 1 is a relative minimum. And if you plug negative 1 into the function, into the original function, you'll again get 4. So we have a relative minimum at negative 1, 4. I'm skipping a couple of the algebra steps, but I hope that's okay. Hopefully you can follow this. In the next video, we'll do one last example.